Hello everyone, this is Dr. Hussain from rxcalculation.com. Today we'll learn how to calculate millimole, milliequivalent and milliosmol using a step-by-step approach. Millimole, milliequivalent and milliosmol represent different things and they are used to express the amount or concentration of a substance in a preparation. So mole is gram over molecular weight, right? Mole measures the amount of substance based on its molecular weight. So millimole is just 1/1000th of a mole. To convert mole to millimole, you multiply the number of moles by 1000. Milliequivalent represents the concentration of ions in a solution, considering the chemical activity and charge of the ion. To calculate milliequivalent, we multiply the millimole by the balance. Milliosmol is related to osmosis, meaning it takes into account the number of particles in a solution. So to calculate milliosmol, we multiply the millimole by the number of species or particles in a solution. So if you see, the equation for millimole is milligram over molecular weight. You can convert milligram to millimole using this equation, or you can convert millimole to milligram using this equation, because molecular weight is always fixed. So you can either convert millimole to milligram or milligram to millimole. And then milliequivalent is milligram over molecular weight times balance. That means millimole times balance. And milliosmol, again milligram over molecular weight times species. That means millimole times species, because this part is same. Milligram over molecular weight, milligram over molecular weight, milligram over molecular weight. So when you calculate millimole, you simply need to divide the weight of the substance in milligram by the molecular weight. Let's read this question first. A solution contains 100 milligram per milliliter. 100 milligram per milliliter of calcium chloride dihydrate. Calcium chloride dihydrate. Let's calculate the molecular weight. The atomic weight of calcium is 40. The atomic weight of chlorine is 35.5 approximately. So 35.5 times 2 equals 71. And then we know the molecular weight of one molecule of water is 18 approximately. That means 18 times 2 is 36. So the molecular weight of calcium chloride dihydrate is approximately 147 gram per mole. You also need to know how to calculate the number of species or number of particles in the preparation. Calcium chloride dihydrate dissociate into one calcium ion and two chloride ions. That means there are 3 species in total. The 2 water molecules are part of the compound's weight, but they do not contribute to the species. Now let's calculate the millimole, milliequivalent and milliosmol. First, we need to find the amount of calcium chloride dihydrate present in 10 milliliter. Since the concentration is 100 milligram per milliliter, you can use the dimension analysis to calculate the total amount of calcium chloride dihydrate present in 10 milliliter. So milliliter cancel out. We have 1000 milligram calcium chloride dihydrate present in 10 milliliter. Now convert this milligram 1000 milligram to millimole. Simply you can use this equation. So millimole is milligram over molecular weight. We know the weight in milligram, which is 1000 milligram. So if you divide 1000 milligram by the molecular weight, you will get the millimole, which is 6.8 millimole. So 1000 milligram calcium chloride dihydrate is equivalent to 6.8 millimole. As I said, to calculate milliequivalent, simply you need to multiply by the balance number. So simply you need to multiply the millimole by its balance number. So the millimole is 6.8 times 2, which is 13.6 milliequivalent. Now let's calculate the mOsmol. Calcium chloride dihydrate dissociates into 1 calcium ion and 2 chloride ions. So the total number of species are 3. So you simply need to multiply by 3. So if you multiply the millimole by 3, you will get the mOsmol, which is 20.4. Let's read this example first. A physician ordered 12 milliequivalent of potassium for a patient. The available potassium chloride injection has a concentration of 20 milliequivalent in 10 milliliter. How many milliliters of this potassium chloride solution should be administered to provide the required 12 milliequivalent dose? So, do we need to use the milliequivalent formula to solve this problem? The answer is no. This is simply a basic dose calculation. Sometimes the physician may write the order in milliequivalent, but it doesn't mean you need to use the milliequivalent formula always. You can solve this problem using simply a ratio proportion method. So the concentration is 20 milliequivalent in 10 milliliter. This is your first ratio. And the patient needs 12 milliequivalent dose. This is the second ratio. You just need to solve X. The patient needs 6 milliliter of potassium chloride injection to get 12 milliequivalent dose. Let's convert this 20 milliequivalent in 10 milliliter concentrations to milligram per milliliter and mOsmol per milliliter. Here I just wanted to show you the different way of concentration expression. So the available concentration is 20 milliequivalent in 10 milliliter. So first we need to simplify this. You need to convert this 20 milliequivalent per 10 milliliter to milliequivalent per milliliter, because we need to calculate milligram per milliliter. So I want to keep the same volume. Simply if you divide 20 milliequivalent by 10 is 2 milliequivalent per milliliter. And as you know, this is the equation for milliequivalent. The molecular weight is fixed. The molecular weight is fixed. The valency is fixed. This is potassium chloride, KCl. It dissociates into K plus chloride ion. So the balance is 1. The molecular weight of potassium chloride is approximate 74.5 gram per mole. As I said, if you see the equation, the molecular weight and the balance is fixed. So we have only two different terms, milligram and milliequivalent. So if you know the milligram, you can convert to milliequivalent. Or if you know the milliequivalent, you can convert to milligram. In this case, we know the milliequivalent. So simply we can plug in the milliequivalent and convert this milliequivalent to milligram, because as I said, the molecular weight and the balance is fixed. It's based on the salt and we cannot change it. So the concentration is 2 milliequivalent per milliliter. So when you plug in 2, you just have to rearrange the equations to solve for milligram, which is 149 milligram. That means 149 milligram per milliliter. So using these concentrations, simply you can convert this 149 milligram per milliliter to mOsmol per milliliter, because you already know the weight of the substance in milligram. So if you see the equation for mOsmol, it is milligram over molecular weight times species. As I said, calcium chloride dissociate into calcium and chloride. So we have two species. So if you plug in the values like 149 milligram, as I said, the molecular weight is fixed, even the species is fixed. So you get 4 mOsmol per milliliter.